and do then is set up some type of an equation there that's going to allow me to find the value of x. All right. So as you look at that, anybody have thought then of what we could do to set up to find x then? What we do to solve for x? Anybody? Nick?
9x plus 79 plus 78 plus 69 plus x plus 84 equals 360.
And there we go. We kind of already talked about that, haven't we? That around that center point, all right, around that center point, those are all going to add up to 360, like he just suggested. So go at it. Set up that equation just as Nate ran it off there for that equation. Absolutely is what we're going to do. The work that we get done with various polygons before is exactly what we're doing right there. All right. Now, if you got that calculator of yours, okay, might be helpful. Then it is going to be helpful to have your calculators out today. So if you don't have those calculators out, you're definitely going to want to get them out. So as you set that equation on that, my suggestion is, go through and walk it around yourself, combine those like terms, 9x and 1x, and then just go through and add up those like terms that you see them. You said 78 and a what? 84 and what else? 69 and a what? 79. Those are added up to 310. And all together, those, as he said, are adding up to 360 degrees, right? So as we set up that equation, that's for me what I'm expecting probably to see. Do you need to list out how many angles were there? 4. Do I need to list out all 4 of those angles separately? Not necessarily. My expectation for you guys is to realize, hey, I'm going to go ahead and combine like terms there, write up the equation, and go solve that quickly. Okay, then you should be able to solve those out right like that. Subtract that 310, what do we got? 350. And what is x? X is 5. We said what, 50? And x is 5. Okay, you locked in x is 5, and just as we've done over the last few days with some angle work, once you find what the x is, you're going to go back in. Okay, now we're talking about an arc, so now we're going to get into some work with the measures of arcs that we have not talked about yesterday, but we're going to start talking about today. So let's go find first off US. So we'll go find arc US. Where's arc US? So arc US, as we can see, is from here. We go the short distance, the shortest distance possible. And it's that minor arc right there, okay? The arc measure, that's what it's talking about, the arc measure. So that arc US, as it opens up, it is the same measure as the measure of its central angle it intercepts with. Okay. So when I opened up and I highlighted arc US like that, what is the angle it intercepts with? Trace it back. U and S act as the endpoints of that angle. And what is the vertex then of that angle? Yeah, V. So when I highlighted that arc of US connects to angle V, right? And so therefore UVS is its intercepted angle. So whatever the measure of that central angle is also the measure of the arc. And you said earlier, yesterday, how many degrees for a circle? 360 degrees. So the measure of arc US is how much of that? So what we need to then look at is, we just locked in X is what? 84? Not 84, 5. 5 and 84 is what I meant to say. Is 5, and 5 plus 84 is? 89. And what's 89 plus 69?
158.
What was it?
158.
158. So these two angles together are making 158. And therefore, the measure of that arc is the same as the measure of that central angle it intercepts. And the measure of arc US is 158 degrees. So today, that's what we want to start working on, is that the measure of the central angle is one and the same as the measure of its intercepted arc, okay? Again, you've never, I don't think, dealt with that ever before. It's the first day through, let's start practicing, okay? So let's use that little bitty skill, and just like you did with angles before, not this week, but you should have done with angles and finding measures of angles before, it's the same basic idea. We're going to play around with it, whatever you kind of need to do with angles, of adding, subtracting. We're going to do that same idea here with arcs. So here, what we have is angle addition, we have segment addition, and we have this idea of arc addition, okay? The measure of arcs formed by two adjacent arcs is the sum of the arcs. Of measure of arc formed by two adjacent arcs is the sum of the arcs, yeah. So in this instance, I want us to go through and find a combination of the measure of an arc, or on a couple of these, looks like I have you to find the measure of an angle. So let's look at that picture and let's go at it. Okay, whatever we need to do to find it out. Add them, subtract them. Are they the same? It just depends on what we got going there. And as I encouraged you earlier this week, I'll say the same thing here. As you find a value, I would do your best to maybe highlight that in your picture. Okay. So we got ourselves what to start off with. We got a 40 degrees hiding up there as an arc, YD. And then we've also give you a central angle, 56 degrees of what? XCD. Those two things will be enough to help us find everything in there at some some time. Okay. So start going through and finding those. I know some of you are already doing. Okay. I'm going to give you about 2 minutes here. Just kind of try that on your own. All right. So let you go at it. I'm going to pause just so that you guys try that on. Okay. XWY. Let's do this. Trace again. Sorry, XY. Trace it out. Again, I can't explain it enough. Trace those out. So as you see, XY, it's referring to an arc, and that starts the whole thing off today. 96 degrees, right? Okay, check my work as well. DXM. As we see DXM, we trace DXM. DX tells us to go this way, M all the way over here. Now, as we do that, I see a 56 starts it off, and then this next piece of the arc, what's that all part of? A 180, a semicircle. So we got a 56 plus a whole semicircle. 56 plus 180 gives me how much? 236. Okay. All right. Keep rolling along here. Now, as we keep rolling along there, again, I trace it out. Again, pencils. That's helpful for you. They're right there. MWX. Find M. Go the direction of W, and we just did that semicircle, right? All right, Y. Where's Y? And MX. Going, here's the semicircle. Keep going, though. Now, we got 180 right there, but then I'm missing that minor arc right there, right? Now, I walked around, I saw a lot of people find me that minor arc, but then how do we find that minor arc? We had this 96 right here, didn't we? A minor arc and a central angle are one and the same measure. So I saw a lot of you bring that arc down to the angle and said 40, 56 was 96, minus that, and that gave me a what? 84, right? So then that 180 plus 84 is? 2 what? 264? Okay. 264. So that's where I was talking about on some of these. Put those measures into the picture. That 84 would be helpful to have there. All right, keep rolling along here. D, W, Y. So I skipped over that X, labeled that W to tell me to go that direction. Man, on that one, it's most of the whole circle. What would make sense to do this one then? Yante? No, yeah. That would make more sense to do 360 minus the 40, right? This one here, sometimes it makes more sense to do the whole minus whatever part, right? 360 minus 40 is, right, 320. Finishing it off here, Y, C, D. We talked about the arc is the same as the central angle. So that's where that 40 degrees is going to happen. Okay, WWX, there it is. It's the central angle. Central angle and the arc, its intercepted arc, is always one and the same. You just got to kind of get that into your head. And we're back to an angle. M, C, what? W. What was that? 96. Great. Now I have my 180 here, but that's not to that one. This 180 is going to go to this one. So as I heard a quick 96 right here, that 90, one more button. That 96 is right there, yeah. Because this is 84, that's a 180. 180 minus 84 is 96, like you said. Okay? It's going to come from practice. The more practice we do, it's going to get a little bit better. But it's very similar to the angles work that we had done before. Now I walked around earlier and passed out to you guys a protractor. Now what I would like you to do is measure out for me two angles here. Go find me angle CBD and go measure out for me angle CAD. So take a minute. Go find me the measure of those two angles. Okay? It'll take me a second and find me the measure of those two angles. Hopefully, fingers crossed, the printer is going to work well enough for us on here. Okay, go find me the measure of those two angles. Fingers crossed again, it's worked out well enough for us. On there. One more time.
Oh, okay.
So CBD. It's actually now you're gonna just kind of eyeball it. Is it gonna be perfect? No, but it should relatively close. So for my CBD, I went ahead and put my 0 right there. And then as I'm opening it up, 0, 10, 20, 30, 40, 50, 60. Where is it going through at? Looks like CBD is going through right about what? Looks like about 70 degrees. Yeah, give or take maybe a half a degree or something, but let's go with 70 degrees like you said. Now, that is considered to be a what? What type of angle is that? It's an acute angle, that's definitely true. But as we just were talking about our vocabulary, that's also a central angle. Let's keep that in mind. Let's keep that vocabulary in mind. That is a central angle because I'm about to introduce you to another new angle today. If you haven't done the other one yet, go do the other one because I want to talk about another new angle. So go find me to measure this next one. Okay, measure out the next one. Give or take, what's this one pretty close to? Should be right about 35 I'm hearing. Give or take a degree or so, but it should be right about 35 degrees. Okay, 70 and 35. All right, so there is a relationship happening on that new specific angle with our old central. What is that relationship? It is half, okay? There is a relationship happening, and it is the measure of angle CAD is half measure of angle CBD, okay? And that's going to be a brand new angle today. So we're going to give you another new vocab out there. That new angle that we talk about, we're going to call that the inscribed angle is half the central angle. So that's a brand new angle today. Central and inscribed. So an inscribed angle is the new guy for today. If you've never heard of an inscribed angle, that's the new one. I don't know why you would probably heard of an inscribed angle. Okay. I always think about like a slingshot. You got D and C as kind of like the posts on the slingshot. As you bring the slingshot back, all right, think about it, just use a rubber band too with your fingers. What happens to that rubber band on your fingers? Keeps getting a little bit more tight, right? And as you keep bringing that rubber band back a little bit, you get two sweet spots. One sweet spot is the central angle. So the central angle is going to be the same measure of that arc that we had up there. And then you keep pulling it back a little bit, and what happens is you keep pulling it back further. That rubber band keeps getting a little bit what? Tighter, right? On your finger. And as we keep pulling back tighter, we get to that second sweet spot. And that second sweet spot is now what we're going to call the inscribed angle. And that angle that's being created as we pull that rubber band back further is going to be exactly half of the angle that was created at that first sweet spot, which we call the central angle. So central angle is always the same as the arc, and the new one today is the inscribed angle, which is always going to be half of that first sweet spot, the central angle. So inscribed angle, that's the new one. Now what makes it inscribed? I think I get it on the next page. So what makes it inscribed is right there. So what makes it inscribed is the vertex is situated where? The vertex, wherever it is, the vertex, if it's situated, whoops, shoot, wrong one, my bad. Let me fit that up. I thought that was the first one. My bad. Let me fix that. What makes it inscribed is if the vertex is actually on the circle. Because if it's at the center, what have we been calling an angle when the vertex is at the center? That's the central angle, which I meant to write in the wrong spot. Okay, that's a central angle. So wherever that vertex is located determines on how we name it, and then therefore is the different relationship in the measure of the angle. Okay. So somebody really quick, give me a name of the central angle up there. What's the central angle up here? AOC. And then now give me the name of the inscribed angle. ABC. Right. ABC, right? Because to be inscribed, B, the vertex, has got to be sitting on the circle someplace. A, B, C. So that's our next vocabulary. We've had a ton of vocabulary this week, especially the last 2 days. Now, what I just said on the other side is what this is saying here. The measure of the inscribed angle is always half the measure of its intercepted arc, or what we also said is slash central angle. The measure of the central angle and its arc is one and the same. We just did that work a few minutes ago on the other side. And then when I say it's half the central angle, it's also half its arc. It's, again, always give you the case. So the measure of that angle B, what you told me a second ago was a inscribed angle. We can write it up one of two ways, and either way is fine. We can say it's going to be half of the central angle. The central angle you told me was AOC, right? That's one way we can say it. It's half of the angle, central angle. Or what can we also say? It's going to be half, why did I say M? Half of its arc. Now trace angle B, the inscribed angle. What arc does angle B go back to? It goes to arc what? AC. So when I keep telling you, if you trace out those angles, trace angle B, and where does angle B go to? Yes, it goes to that arc AC. So it's half of the measure of arc AC. Now AC and the central are the same measure. They are the same. The inscribed is half of both of those. Okay. All right, we talked about it. Let's use it. So let's look at number 9. Go find me where angle D is located. Put that 25 in there. Where's 25 degrees going to go? Label up that picture. 25, 25. Angle D is right there. Now, where is that angle D located? Tell me if that is a central angle or an inscribed angle. It is inscribed. Okay, with it being inscribed, I like to, especially since we're starting this off for the first day, label these out. The more times you know what you're talking about. Okay, now think about what we just did on the other side. We want to go find what? X. And where's X located? X is representing a what? Central. How am I going to do X? Yate? Right. So what I'm doing here is I'm going to take it out to the central. So I'm going to double that. I'm going to double it. That's the relationship that's happening here. 25, that's going to become 50, like you said. So that's going to be 50 degrees because that relationship here is half here, right? Half of 50 gives me 25. So if I want to go the other direction, I got to double that. That's you're going to do one of those two things, okay? All right, that's it. Let's take the next one. Go find me AOC. Where's AOC located? AOC represents what? 40, and 40 is a central. Now trace it out. What does ABC represent? Inscribe. So when I go find ABC, ABC is right here. That's what I want. That's an inscribed. Again, it might sound like, I don't know, juvenile or something. Like, why do I keep writing out central and inscribed? Because I've done it for enough years, I know students don't necessarily know the difference between the two. Okay, there's my 40. Go find me that question mark, that X. So what's that answer going to be for the inscribed angle ABC? There you go. So going from the central backwards to the inscribed, it is half, 20 degrees. Okay, we're going to do some more work with that. Now, with that more work coming, let's come back from yesterday. I'll come back to that and give you another quick minute here. Let's do that vocab. Go. I say quick minute, let's do a quick 2. Go. Go, go, go. Go through that vocab, give me an example of each of those. There could be more than one answer on that. If you look back to that vocabulary from yesterday, all right. Gotta know the vocab, you gotta know the vocab. The pictures are gonna keep getting a little bit more involved each day, so I'm gonna keep hammering you guys on that. When I move into your books next week, when I say this angle, you gotta know which angle I'm referring to like that. You can't be there thinking, what the hell is he talking about? What angle is he talking about up there? Start for some reason. Minor arc is what? Oh, sorry. Oops, sorry. I meant to say, yeah, I meant to say major arc. Let's try it again. Give me a major arc. E, F, A. Most definitely major arc there. And a major arc should be using how many points? 3. E, F, A. That is correct. Okay? All right. With all of that right there, let me take a quick look there on the back side. Yeah, let's just do that top one real quick and call it a day. All right. On that top one. All right. We did a bunch on that with the arcs and angles. Let's do, it's really quick here for our time's sake. Let's do on the E and the F. Go find me the angle AOB. Let's put that 30 in there. Where's angle AOB at? What does AOB represent? It's a central angle. Okay. So when you put AOB in there, which is a central angle. It then says find me the measure of arc AB. So what's the measure of arc AB? It is also 30. I can't stress that to you enough, that the measure of the arc and the measure of the central is one and the same. Go find me arc PR. Where's PR at? Go highlight it. PR is right here. It's 50 degrees. Now what's PQR represent? PQR is a what? Inscribed. Why is it inscribed? Where's Q located? On the circle. And because it's on the circle, that is considered to be inscribed. And what is that relationship? It is half. Going from the arc, Q's inscribed. As soon as you tell me it's inscribed, I'm going from the arc to the inscribed. It is half. And half to 50 is 25. All right? That's the part people screw up the most. Okay? We're going to do more practice with that into next week, and really for the next couple weeks. I'm going to